Hey class, today we're going to learn about parallel circuits. Just like with series circuits, we're going to learn to solve for current, voltage, and resistance anywhere in a circuit. Let's review some rules first. First rule is that the voltage is the same everywhere in a parallel circuit. Every outlet in your house gets 120 volts because your house is wired in parallel. The current is going to split up, meaning that if your house has a power line coming in with 10 amps, that 10 amps might get split up where you get 5 amps to your bedroom, 2 amps to your bathroom, and 3 amps to your kitchen. We also have Ohm's law to use at any time, and we also have a parallel resistance formula right there that will be given. I know I never really derived that for you, but that's an equation that you'll be given to solve for total resistance of a parallel circuit. All right, let's go ahead and start solving some problems. In this first problem, it's a very quick and easy problem. It's probably one of the easiest of any parallel circuit problem. We have two resistors, two light bulbs in parallel attached to a 120 volt source just like your house. Whenever I see two resistances right there, I know right away I can solve for the parallel resistance. So I can do 1 over 12 plus 1 over 24. I can put that to the negative first power, and I should get 8 total ohms of resistance. Now, that might be surprising because why is the resistance less than the other resistors? Because in series, every time you add a resistor, you get more resistance. But keep in mind, this is a parallel circuit, and every time you add another path, another branch, you are adding another place for electrons to go. Therefore, the resistance goes down. Now that I know the total resistance is 8 ohms, I know the total volts, and I know the total resistance. I can use Ohm's law to solve for the total current. So 120 over 8 gives me 15 total amps. I also know that every branch gets 120 volts, which means I could actually solve for the currents without needing to do those first two things. I know two things here, I know two things there. I can use Ohm's law, so I can do the voltage at A divided by the resistance at A, and I can do the voltage at B over the resistance of B, and I get 120 over 12, which gives me 10 amps, and I can do 120 over 24, which should get me 5 amps, and what do you know? These two, 10 plus 5, do give me 15 amps, so I can be pretty sure that my problem is right. Moving on, a little more challenging. In this circuit, we have 3 amps of current going through A, which has a resistance of 6 ohms, and we have only a 12 ohm bulb here. What we can do right away, I see two resistances. I could solve for the total resistance. I could do 1 over 6 plus 1 over 12. Put that to the negative first power. And I get a resistance of 4 ohms. I also know two things about A. I know the current going through A, and I know the resistance of A. So I could solve for the voltage at A. I could do VA equals I of A times R of A. And I could do 3 times 6, and that gets me 18 volts. Now what you should know is that everything gets 18 volts. This gets 18 volts. B and the total, everything here is 18 volts. This, object B, gets 18 volts. And now I know two things about B. So I can solve for the current in B by doing the voltage of B over the resistance of B. So I could do 18 over 12, and I can get 1.5 amps. And then I could solve for the total current. I could also do the 18 volts total divided by the total resistance. So 18 over 4 gets me 4.5 amps. And if we look, I get 1.5 amps going through B, and I get 3 amps going through A, and if I do 3 plus 1.5, I do get the 4.5 amps total coming out of the battery. So I can be confident that I'm correct. Last problem. I would say this is probably as tough as they get for parallel circuits. I have 12 amps coming out of the battery, so that would be my IT. And then I get a 4 ohm resistor, I have another light bulb resistor, and then I have another resistor that has 2 amps, so this would be the current going through C. What makes this problem difficult is I don't know any of the voltages, I don't know the resistance of B, I don't know how much current splits up and goes to any of those branches. There's only one thing I can really do, so if you want to think about it for a minute, you can go ahead and pause it right now and see what is the only step I can do. The only step we can do here is working with C. Since we know that the resistance is 12 ohms and we know the current is 2 amps, we could actually solve for the voltage at C. So we could do Ohm's law, I times R, and we could do 2 times 12, and we go ahead and we get 24 volts. And hopefully now you can remember that that means everything is 24 volts. The battery is 24 volts. A gets 24 volts, B gets 24 volts, and now we're well on our way here to solving this problem. So I could go ahead and write that my battery is a 24 volt battery, this is 24 volts, B gets 24 volts, we already know this, that gets 24 volts. So now it becomes much easier. For example, we know A has 2 things about it. We know it has 24 volts and 4 ohms, so therefore we can solve for the current. We could do voltage at A over resistance of A, and we can get 24 over 4, and we get 6 amps. What else could we do? We could actually solve for the total resistance. We could do R equals total voltage over total current, R equals V over I, and we can get 24 over 12, which would give us 2 ohms. And again, I know that seems weird because we have a 12 ohm resistor and a 4 ohm resistor, and we have a total resistance of 2, but just remember that resistance goes down. Resistance in parallel is always going to be the total resistance will be less than all of the resistors in the circuit. Moving on, we could then solve for the current going through B. We could say that we have 12 amps total, and we know that 6 go to A, and we know that 2 go to C, and that means that the leftover amps is going to be 4 amps going to B. And now we know 2 things about B. We know the current and we know the voltage, so we could do R is equal to V over I, and we could get a resistance of 6 ohms. And then to check if we're right, what we can do is we can check it with our parallel resistance formula. We could go ahead off to the side and we could do 1 over 4 ohms plus 1 over 6 ohms plus 1 over 12 ohms. And I'll go to my calculator right now and check that out. And we do, in fact, get a resistance of 2 ohms. So again, that tells me that we are pretty confident that we did the problems correctly. So that's pretty much it. I'll give you one little hint. When I do the parallel resistance formula, what I normally end up doing is saying something, or I type in this into my calculator. I'll say 2 to the negative 1 plus 4 to the negative 1, or whatever the resistances are, and then I'll hit enter, and then I'll do my answer to the negative 1. So go ahead and look for that negative 1 button. It just makes it a little bit quicker and easier to put in your calculator. It might save you a couple minutes. That's about it. If you have any questions, I'll make sure that I'm in the chat, and I'll post the solutions as well. Thank you very much.